Let's begin. Today is August 29th, 2024, and we're solving the Daily Turing Machine Puzzle. Today's puzzle uses the following 5 criteria cards. Criteria card 5, 8, 12, 16, and 20. And the puzzle uses the green verification cards. The code above is your way to get more information on today's puzzle by searching the code on turingmachine.info. Let's go solve. So in the grid above, we've got our 5 criteria cards. On the top row, we've got criteria card A, criteria card B, and criteria card C. On the bottom row, we've got criteria card D and criteria card E. So criteria card A looks at our first digit, the triangle digit, and will let us know whether its value is an even digit or an odd digit. Criteria card B will look at the 3-digit solution and will let us know how many of those digits are 1. Are there no ones? Is there a single one? Perhaps 2, maybe even all 3 are 1. Criteria card C will take a look at our first and last digits, triangle and circle, and compare them. So should the value of triangle be less than circle? Should they be equal? Or should the value of triangle be greater than circle? Criteria card D will look at our 3-digit solution and will let us know a little bit about the ratio of even to odds. Should there be more even than odds, or should there be less even than odds? And finally, criteria card E, again, will look at our 3-digit solution, but this time tell us a little bit about its structure, so to speak. Specifically, it can tell us whether there are no repetitions, or all the digits are unique, as in the example 125, or it could tell us that it has a double number, where there's a repeating digit, as in the example 112, or it could even be a triple number, where it's a single digit repeated 3 times, as in the example 222. And remember, the objective of today's puzzle is to find a unique 3-digit code that abides by all the 5 criteria cards we just described. Well, let's start off with an initial proposal of 314. So the first thing I want to find out is what kind of digit triangle has. So let's go ahead and test criteria card A. Okay, so the Turing Machine does not approve of my choice. Notice that I do have an odd 3 in for triangle, but it disapproves. So basically it's telling me that triangle should actually be an even digit. So let's go ahead and type that up in our notes. That triangle is an even digit. And of course, since it is even, I can cross out all of the odds. So I'll cross out 1, 3, and 5. Next, I think I want to find out a little bit about the ratio of even to odd. So let's go ahead and test criteria card D. Okay, so it does approve of my proposal. Notice that I do have 2 odds to a single even. So that means that there are less even than odds. So let's go ahead and type that up in section D. And again, that's that even is less than odd. And notice that since we already have demonstrated that triangle is even, that means that both square and circle must be odd. So let me quickly just write down a note here that square and circle are odd. And of course, since they are odd, I can cross out the evens in both square and circle. So crossing out the 2 and the 4 in each. So that means we're looking at a solution that is even, odd, odd. And well, let's take a look. Since we do have 2 odds, we do have this criteria card. Obviously, it can't be a triple number since we do have 1 even to 2 odds, but there could be a double, or potentially maybe they're not even no repeat digits. So let's go ahead and test criteria card E. Okay, so the Turing Machine again approves of my proposal. I do have 314, all unique digits, no repetitions. So the Turing Machine confirms that the solution has no repetitions. So let's go ahead and type that up in our notes in section E, that the solution has no repetitions. Okay, now obviously we can't cross out anything there, but I think we've established a good understanding of what the solution sort of looks like going into round 2. And since we did complete our 3 Turing tests for this round, we're now going into the phase where we'll be discussing how to construct a good second round proposal. So the one thing that we did not test was criteria card B, the number of ones. At this point, since there are no repetitions, we're either looking at no ones or a single one. And then we also didn't test criteria card C, where we compare triangle and circle. So we'd be comparing an even to an odd. And so, notice also, there's no mention of square at all. So somehow that square value is going to be forced into something. Now I'm not sure if it could be our single one somehow, if it does exist. The other possibility is if it doesn't exist, then we know we're dealing with 3 and 5. So that may be a more plausible possibility, is that if you don't have a 1, you know you have 3 and 5 for sure. Whereas if you do have a 1, well, you're not sure where it goes. I mean, you still don't know where the 3 and 5 go, but at least you know for sure it's 3 and 5. And really it comes down to these 2 criteria cards to find our solution. So let's see how they interact. So again, let me go with the premise that there is no 1, and so we have 3 and 5. So what could we test? It could be, let's see, trying to see how we could sort of figure out some relationship between the 2 and the 4. And again, if there are no 1s, the 3 and the 5. I wonder if it could be, yeah, if there are no 1s, then perhaps triangle is larger than circle, meaning that 4 is bigger than 3. And of course, since there are no 1s, that means square would be 5. So let's try that out. Let's go with 4, 5, 3. Okay, so yeah, it looks like we only have 2 tests to make. I'm trying to see if we can deduce one of the criteria cards. So, well, I could see a possibility where even, well, yeah, I'm trying to see, because if I still have 2 and 4, it looks like both 3 and 5 are both greater than 2. So it would almost have to be where, yeah, a triangle is greater, and it would point to the 3. Let's go ahead and test criteria card B and see what we get. Yeah, so in fact, yeah, since I don't have a 1, the Turing machine approves of that. So let's go ahead and type that up in the notes in section B. And that is that the solution has no 1 digit. And of course, we can now cross out the 1s for both square and circle. And so, yeah, I'm trying to think of, can we deduce that it's C? I mean, sorry, that C is in fact triangle is greater than circle. Well, we know it can't be equal since we're dealing with odds and evens. And yeah, I think I want to say we can deduce it, because again, if it's the other case where it's less than, I mean, there are too many cases. 2 is less than both 3 and 5. And so I mean, 2, 3, 5, 2, 5, 3 would be ambiguous. But what about 4, 5, 3? That's where it would be less. But how would you establish that for sure? Because it couldn't be 4, 3, 5. At least that's my proposal, and the only way is if triangle is greater than circle. Yeah. Let's see. Yeah, I'm going to take a risk, and I'm going to say, I'm going to deduce that it's going to be triangle greater than, because I think the other case where triangle is less than, there are too many possibilities. Yeah, 2, 3, 5, 2, 5, 3, and even 4, 5, 3. Yeah, the only thing that makes it different would be 4, 3, 5. Oh, wait. Oh, did I type that? Maybe I typed it in wrong. I did type it in wrong. Oh. I meant to type 4, 3, 5. Okay. Well, now I am concerned. So, yeah. My goof up. So, yeah, let me test C. What? Okay, now I'm really confused. Well, it worked out. So what is it that, oh, you know what? I was comparing triangle and square towards the end instead of triangle and circle. Okay, well, we'll just have to chalk that up to being a little bit more careful next time. So, but let's type it up. So it is true that 4 is greater than 3, so triangle must be greater than circle. So let's go ahead and type that up. Triangle is greater than circle. And just to make sure, so let's see, 2 is not bigger than either 3 or 5, so we know it can't be a 2 for triangle. And 4 is not greater than 5, so we'll cross out the 5 in circle. And so 4 is larger than 3, and there can be no duplicates. So let's cross out the 3 for square. And that looks like what I typed up. Yeah, 4, 5, 3. Okay, so thank goodness that I was thinking clearly during the construction of the second round proposal and not towards the end, because I definitely could have sabotaged the whole solution. Okay, so yeah, it looks like 4, 5, 3 is our solution. The only thing that we missed was A, but we corrected that. That was that the first digit had to be even, and it is. Okay, well, let's go verify the solution of 4, 5, 3. Okay, fantastic. And let's see, well, I think we did pretty well. We did test each of the criteria cards once, and A was the only incorrect. And we did A, D, E the first round. So let's go type that up. So A was incorrect. D, E were both correct in the first round. And the second round, we only had to do 2 tests. And so how do we do? Okay, so we beat it by 1 question. Obviously, I think if I had not flubbed it towards the end, again, I was comparing triangle and square when I should have been focused on triangle and circle. I think My intent was to actually deduce C, because there seemed to be a lot of ambiguous solutions. But, we still got the win. Just try to be careful next time. It happens from puzzle to puzzle. Well, what are your thoughts? Did you like the puzzle? Were there any other things in the video that you thought I could improve on? Or how did you solve it? And if you liked the video, please do give it a thumbs up so that more people can find the channel. And of course, subscribe to not miss any future videos. Well, until next time, have a great one.